Video, we are going to find all angles with a given trigonometric value. In this video, you will also need access to a calculator. You will not see me using the calculator, but I am going to use my TI-84 calculator to make some of these calculations because they're not the traditional unit circle values. So what are all the angles that have a cosine of 0.57? So we're looking for all the angles that produce an output of 0.57. So again, like I said, it's not one of the traditional values that we've seen before. It's not like square root of 2/2 or any of those type of values. Doo-doo. That is not even close. Let me undo that. Doo-doo. Let's scoot this over. No. Scoot this over just a little bit right there. Still not straight. There we go. Yeah, that didn't work. But we're just going to pretend like this is directly in the origin. And we're going to look at any place that cosine can be 0.57. So here's something to think about. Cosine of theta is going to be an x value. So we're going to look at every place that x is positive. So here in quadrant 1, x is positive, and here in quadrant 4, x is positive. So this angle is not going to include this quadrants over here, quadrants 2 and 3. All right, so next thing I'm going to do is I'm going to input this into my calculator. Remember, my calculator is going to be looking at the domain. Basically, really, it's looking at the domain here in the first quadrant. But that does not mean we can't rotate it the other direction to be in the fourth quadrant. So using the calculator, I get cosine of -1, so the inverse cosine of 0.57. This is what I'm going to input in my calculator. And in the calculator, you're going to use second cosine to get that cosine inverse. And we get, and if your calculator is in degrees, you'll get it in degrees. If it's in radians, you'll get it in radians. You can find what it is in the mode button of your calculator. But I get 55 because I'm using degrees, 55.25 degrees. Now let's say I go back and I use radians. And this pinkish color is going to be the radians just to distinguish between the two, because radians is going to be a decimal and not something that contains pi. Although this should go on for a very long time because it does include pi. Okay, so now looking at this, I am going to draw my angle 55 degrees. So this is 45, it would be in half, so 55 would be a little bit higher up. And there's my angle there. All right, so the next thing I have to do is, again, this is at 55.25 degrees, which means we are also at negative 55.25 degrees. We're going to make our way down to someplace about there. And now we have the angle here, 55.25, the angle here, which is negative 55.25, or 0.96 radians. And now we just have to identify the coterminal angles, which means basically the angle going all the way this way, all the way around the circle. So we have, oh, and then the points. Let me put the points here. I'm going to use this pink color. This is going to be 0.57. If I input sine of 55.25, if I'm in degrees, or sine of 0.96 if I'm in radians, we get the output of 0.82, and that's my y, 0.82. And so that's what we're looking at here. Here we're going to be looking at 0.57, comma, negative 0.82. And my coterminal angle, I'm going to take 360, subtract that 55, so 360 minus 55.25, and I get, let's see, let me subtract this. 360 minus 55.25, which is 304.7. And then I could keep doing this because remember, we can go around in circles. I could go another 360 to get to this point, or I could do another 55 to get to this point from 360. So we're continuously going in. Since we're supposed to find all the angles, I'm going to state this in a different way. I'm going to do the 55.25, which is this original. And then I have to get to this point here. Plus k times 360, because then I'll get here again, and we keep hitting this point here. Or, if we're dealing with radians, 0.96 plus 2 pi k to get to that point. All right, so this is getting to this first point here. What about this second point? If we keep going around this circle, well, I can say that this is negative 55.25 plus 360k, and then that would take us to this point right here, and or negative 0.96 plus 2 pi k, or 2k pi would actually probably be a better way to write this. So in conclusion, the angle measures that have a cosine value of 0.57 are 55.25 and any other rotation around a full 360, and negative 55.25 or any rotation around that hits that point, which is 360 times k. All right, guys, I know that this part was a little bit arbitrary because you're thinking of just finites, but again, we continue going around this circle over and over again. This is like a running track. I could hit this point multiple times, but to hit this point again, I would have to go 360 degrees. To hit this point again, another 360, and so on and so forth. And that's where we get these values here, is those extra times that we go around the circle to hit that point over and over again. So there you have it. There is one more part to this example 3, but it's just about tangents and looking at how the tangents work. It's going to be the exact same way here. You're going to be looking at what coordinates your values are positive or negative, and exactly how far away you are from that x-axis, basically your reference angle from there. All right, guys, so if you have any comments or questions, always feel free to ask. Also review the second part of this example, and I will see you in the next video.